Why do you need to know about decontamination? As a person working in a high containment or critical environment facility, you probably won't be responsible for whole room decontamination processes or possibly even decontaminating equipment or instrument on a regular basis. But you do want to know what to do in the case of a contamination of some of your tools or a spill. And in general, you want to be able to understand what the others are doing so that your work will be more efficient. In this presentation, the decontamination being discussed is removing living organisms or microbes from the environment. So let's talk about terms, because these 4 terms that are listed on the slide are frequently misused, misunderstood. There's cleaning, there's decontaminating, there's disinfecting, and then there's sterilizing an item. Let's move through these slide by slide. Cleaning is pretty simple. It just means removing the soil from the item, because otherwise the decon efforts don't come in contact with the contaminants. Simple, right? But since we're talking about microbes, you remember you're probably not going to get sick with just one colony of a bacteria or one virus. It's going to take a load. So the term decontaminating means you're going to reduce that load. You're going to lower the hazard. It's not sterile, it's not gone, but the load is such that you won't get sick. It's kind of like wiping a table in a restaurant. You know it's not sterile, but it's clean enough to eat off of and not cause illness. Disinfecting an item means that we're going to remove all the known pathogens. So what this generally speaks to is choosing the right type of chemicals or agents or procedures to remove the things that we already know are going to cause us illness. An example of this would be like cleaning a hospital room. The reagents, the chemicals, the processes that are used make it such an area that it's not going to encourage illness, but it's not a sterile environment. Sterilization is actually removing all microbial life. It has the extra effect of killing spores, which are possibly the most difficult to kill. So, if an item is sterilized, it has no living organisms on it. The instruments used in surgery are sterile. There's nothing living on them when they're removed from their packaging. How do you know what to do? Well, this is a question that the safety officers need to address regularly as they consider how the labs and rooms and equipment need to be used. But it's also a question you'll want to ask, because you'll take your equipment and into these rooms and labs, and you'll be in these rooms and labs. So let's think through some of the questions that need to be asked so that you can choose the right method of decontaminating your items, and so that you understand what's going on in the rooms that you're going to be working in. You'll learn much more about how to decon many items necessary for your work during the skills training on campus. But for the moment, consider how you'd make each of the items on this slide clean for use after they were decontaminated with microbes. What would the drawbacks be? You need to know what you're removing from an item. Now, obviously, you're not going to worry about lipid viruses versus vegetative bacteria. That's just not your responsibility. But the slide, and the next slide in particular, are to demonstrate how it's not easy necessarily to remove bacteria from an item or from a room, but it's much more difficult to remove a fungus or a mold that's producing spores. So let's look at the next slide as well. The top image is just a graphic of a spore-producing fungus, and the bottom image is a bacterial cell. Well, now that bacterial cell has a plasma wall, and it's not particularly impermeable. You can kill it with probably 10% bleach, any number of chemical reagents. But the top spore-forming fungus is much more difficult to kill because of the nature of the walls. So that's only said because there will be times when labs and rooms, even items, take hours, many hours, if not days, to decontaminate. And this is why. It's just more difficult to decontaminate or sterilize some items. Well, this question seems to be a bit obvious, doesn't it? I mean, what are you going to do with the item once you've decontaminated it? But I think we really need to think about this, because are you going to work on that item where it is? So you're just decontaminating it so that you don't spread the contamination or you don't hurt yourself? Are you going to remove it from that space into a public area? Or maybe even you're going to dispose of it, so that high level of decontamination isn't necessary at all. See, these facts can make a difference in the choices you make about decontamination. So, you're going to get that call someday. Come and fix this thing. And they may not even tell you what the thing is, but you can bet it's going to be contaminated. If it's in a lab, you're going to want to make it cleaner in such a way that it's not going to hurt you or others. So, to wrap up what we've just talked about, before you start working, before you touch that thing, decontaminate it. Clean off what's on it, remove the soil, and then make sure it's disinfected or sterilized, whichever, so that it's safe for you to work on and or for others to work with. This slide shows us some methods of decontamination. Beyond the manual chemical decontamination, you probably won't be responsible for the others. Heat and pressure decontamination, that generally has to do with autoclaves. You may fix an autoclave, but you won't put your items in to be sterilized. Gas decontamination, you won't be responsible for decontaminating a room by gas methods, but it's always good to understand these methods. You may need to use a chemical wipe to prep an area for repair, or you may need to saturate the whole area for a short time with a disinfectant. Different chemicals work best on different microbes, so you need to read the labels carefully and ask questions. It's probably best to ask a safety officer because they work with these all the time. It's their job. And terms are confusing, even when the items are regulated by the EPA or the FDA. So let's look at the next couple slides. If you look carefully, under the heading Neutral Disinfectant Cleaner, there are some interesting words used. It says this particular product is staphylocidal, and then it goes on to say it also kills salmonella and funguses. But cidal means kills, so it kills staph and salmonella and some fungus. but it also says it's mildew static. So that means it doesn't kill the mildew, but it slows the growth. See, it's good to check the label. It's good to check the label, and it's good to ask questions, because this particular product is interesting as well, and you wouldn't know it if you didn't ask somebody about this particular label, because it says it kills funguses. So why is it called a disinfectant? Well, I don't really know, but this wipe should only be used on a hard surface. It won't kill anything, viruses, bacteria, fungus, if it's used on a woven item, like the covering of a chair or carpets. So it's good to ask the safety officer, is this the right thing to use? What should I use to clean this area? Here's a fact that you just wouldn't believe. 10% bleach is going to be a more effective disinfectant than 100% bleach. And that's because the water helps it permeate the item. Some labs use 10% bleach, and others prefer ethanol, just straight ethanol. And part of the reason is bleach is corrosive, so you don't want your plastics and some fabric coverings to become brittle. And part of the reason is ethanol evaporates faster. You have to leave bleach on an area longer so it's not as quickly used, and it kind of streaks. People are funny about the disinfectant they choose to use. So again, ask the safety officer. No one chemical is best for all bacteria. There's no one-stop shop. So read the instructions, follow the instructions, ask the safety officer. Okay, let's talk about heat and pressure decontamination. Generally, what you'll be using, or what is used, are autoclaves. And the 3 autoclaves on this slide are just different types for different purposes, but they all work on the same principle. An autoclave uses high pressure and high temperature steam to kill all pathogens. So something coming out of an autoclave is sterile. Basically, a steam autoclave is a pressure cooker that uses steam under pressure as the sterilizing agent. The increase in pressure allows steam to reach a higher temperature and achieve better penetration of the items. The items that are sterilized in an autoclave have to be bagged or contained in some kind of tray. The bags are generally this orangish color shown on the slide, or red. Rarely are they clear, but there are some. And they'll always say biohazard, they'll have the symbol, and they should say autoclave safe. They're made to withstand those temperatures. Instruments and tools can be autoclaved in metal trays. This slide just outlines a very general way that an autoclave works, talking about the temperature and the pressure and the time. There are other choices to be made. You can sterilize faster or slower. It's not probably going to be your responsibility to determine what's in the autoclave and the parameters of the sterilization. But one thing you can know is that this often has an unpleasant odor. And so it's not that something has gone wrong, it's in fact something has happened correctly. When working with autoclaves, we depend on the fact that the items coming out are sterile. So it's real important that we know that the autoclave worked correctly, that it reached 121 degrees, and that it held that temperature for X amount of minutes, for a certain amount of time. So we check these functions with indicators. Generally, those indicators are what we call chemical indicators because they're sensitive to heat and or temperature. See the bag over here on the slide that has the piece of tape on it that has the white stripes? Well, that bag hasn't been autoclaved yet, and that's why the stripes are white. But after the temperature of 121, the stripes have turned black. So we know at least the autoclave reached temperature. But that tape doesn't tell us that it held the temperature and the pressure for the right amount of time. There are some people who still use tape indicators for an autoclave check. It's not that it's wrong, it's just not the approved method currently. These strips and the vials over here both indicate, by different methods, color generally in both, the amount of temperature, 121 degrees, and the fact that that temperature was held at least for 15 minutes. That's what changes the color in these two indicators. So here are two important takeaways from this presentation. To check an autoclave, the function of an autoclave, you need to know how long the autoclave kept the items at a certain temperature. At least 15 minutes at 121 is generally the temperature and time you want. And the second thing is, and this is important, not everything can be autoclaved. Autoclaves decontaminate small items, but there's still the waste, the liquid waste that comes out of labs that has to be decontaminated. And so these high containment facilities or critical environments have what are called effluent decontamination systems, EDS. And they are used to decontaminate all other waste coming from lab areas, sinks, toilets, drains, water fountains. But the same principle as an autoclave is used. All that liquid is brought into these tanks, it's brought up to temperature and held for a certain amount of time, and then in sync with the city waste system, it's dumped into the city water. Temperature and pH is determined before that dump is made. Everything is regulated. This is not anything that is just happenstance or on need be basis. It's all timed and regulated, measured. Let's talk about this answer. Are the contents of this bag sterile? According to that indicator tape with the black lines now, yes, the contents are sterile. But remember that indicator tape and the change in color of the stripes only indicate that the autoclave has come up to the determined temperature. Presumably that's going to be 121 degrees, but that tape doesn't tell us anything about the amount of time that the autoclave held at 121 or really the pressure that was created. So that tape is true, but it doesn't tell us everything we want to know. We won't spend a lot of time on gas decontamination because that more than likely should not be your responsibility. Gas decontamination is used to decontaminate a large area, an entire lab, sometimes even an entire building. And the type of decision needed to do this is made by the facility director and by the safety officer. So, not your problem. I think, though, that it would be wise to understand what gas decontamination is and some of the different methods used. So let's start in. Gas decontamination uses toxic gases to sterilize all microbes. So everything in that area everything living that was living in that area will be killed. Gas, of course, penetrates everything if given the right amount of time. Certain gases kill certain microbes better than others. But like with the chemicals we sometimes use in chemical decontamination, there are drawbacks to different gas decontamination methods. 4 of the most common methods are chlorine dioxide, formaldehyde, ethylene oxide, and vaporized hydrogen peroxide. That's usually called VHP. So some of these have been used for a long time, decades, and we've come to understand the toxicity created, and they're very rarely used anymore. Formaldehyde is rarely used because it's carcinogenic. It also smells. It has quite a pungent odor, and it leaves a residue. Ethylene oxide is carcinogenic. We usually don't use ethylene oxide for an entire room. We may use it for a large box or an area, and it is explosive. Chlorine dioxide is used on occasion. It creates a dense green fog. And it has quite a smell as well. The most common gas decon method is VPH. It's effective and it has no vapor, but it does require an amount of time. What the process includes is the cleaning crew and the safety officers clean a lab or an area a little more than even the scientist would when the scientist leaves. They take everything out that doesn't need to be gas deconned. They put indicators in the crooks and the crannies of the room because they want to make certain that the gas has penetrated even those deepest areas. So the indicators are in the hardest areas to reach. They close and seal the room, and then the gas begins. After the gas has penetrated the room, of course it's turned off, and the room sits sealed with the gas for an amount of time. Then you have to remove the gas and let the room come back to normal conditions. The reason you might want to know about decontamination and the whole process is because of this. You'll get a work order to clean, or not to clean, to repair something or to install something in a lab that's considered hot or dirty. And of course you can't you can't work in that area until it's been deconned. So the scheduling of your work is going to depend upon the scheduling and the effectiveness of the decontamination of that room. And deconning is not fast. So your work order is going to be slowed down because of a slow process. And I think it's just good to understand why those things happen. The last part of deconning, of course, is making certain it was efficient. And we've talked about this. To do that, the safety officers use indicators. There are biological indicators that have bacterias and funguses embedded in them. So the indicator is taken out of the room that's been deconned. It's put into an environment where those bacterias and funguses should grow had they not been deconned. And of course, if they don't, that means the process was effective. If they do grow, that means the process needs to be repeated. And that takes a long time because it takes sometimes weeks for those funguses to grow. Bacteria grows quicker, but it can take a long time for a biological indicator to tell us if decon has been effective. Now, there are chemical indicators also used, which just indicate that the exposure that the gas or the chemical has touched all areas. And those chemical indicators are rather quick. So the safety officer will probably use both, and she'll tell you one has come back and it's good to go, but you're still waiting on the other. Again, I just think that helps you if you have an understanding. This slide only presents an introduction to filters used in critical environments. You'll learn much more about filters and how they work, particularly in HVAC systems, during your on-campus skills training. Ionizing irradiation is a method of killing bacteria and some funguses in some processes. Usually food and medical devices are the two items that are decontaminated with ionizing irradiation. It's not very often at all used for lab waste. And again, I'm just mentioning this method so that you will have heard of it. And no, it won't make anything that you're using radioactive. Sonicators that are used in labs are generally used to clean an item, not necessarily to disinfect it, but they work on the same process that sonicators at the jewelry store work. It's an ultrasound wave that releases, if you could say that, dirt from crevices. So these are used sometimes in labs to clean up delicate instruments or areas that other brushes or wipes can't get to. Processes that involve large animals in labs create unique challenges for decontamination. Tissue digesters combine heat and chemicals in almost the same way as an autoclave or an EDS system to sterilize everything. They destroy the protein, they burn everything except a little bit of mineralized bone. That's all that will be left. Tissue digesters are incompatible with anything that's not tissue-based. They're very large vats, and you can kind of see an example of one here on the slide. They're almost always in a room by themselves. They're large because the carcass has to fit inside, and then the chemicals and the pressure of the heat, and they have to be drained out into the water system. No equipment can go into them. So this wraps up our presentation on decontamination. Again, I really want to let you know that the type of decontamination that safety officers and scientists speak of is a really deep sterilizing situation, a process, and you're not responsible for that. What you'll be responsible for is keeping yourself clean and safe, and keeping your equipment and your tools clean and safe to use. That's where the second bulleted item comes in. Some items can't be just wiped down. Some tools, some items, some of your equipment can't just be wiped down and taken out of a lab. Some cannot go through an autoclave because, in a BSL-3, remember, there will be a pass-through autoclave. You can't put your things in there, some of them. They just have to be left in the room until it's been deconned. Generally, that's going to be gas deconned. So it creates a situation where you just have to think through the entire process before you even begin it. Because if it's a tool or piece of equipment that you use daily and you can't bring it out, you want one that you can leave in and that you can replace to continue to work.